the risk for leakage is still quite high.
We are currently in the middle of leakage solving chaos. We don't know if we're trying to save something that it's unsavable.
The first rule of Resin Infusion is to not try to fuse if it leaks. We're very close to the decision on why leaking. Let's do it. Let's see what happens.
Success or disaster?
Yeah, let's just do it. The next step now is to start with the main sheet beam. Yeah, now we're just gonna do some XPS styrofoam pieces, basically with this shape, so that we will get a continuous radius here. This part where we just need to fill up with something here. It's not going to take any load or anything. So we just did this piece as a template, and now we try to cut out some pieces in the XPS styrofoam. Okay, so the day has finally come to start with the beam. There are some small air void or air bubbles or voids on the flange here that we're going to use for the sealant of the vacuum film that we have tried to seal up as good as possible. Yeah, and we have tried to seal the beam part down here, so to make sure that it's really sealed as well. So the idea now is to lay up the carbon for the first half of the skin, or whatever you want to call it, outer skin, inner skin, not sure what is what here.
Before we start laying up any fibers and make the surface sturdy, we put this tape on. This is where we're going to have the tacky tape for the vacuum bag later on.
First piece in place, but to be really sure that everything stays in place, we're going to use this, I don't even know, it's some kind of spray glue that you just spray a very thin layer of so that the fabric stays in place. I mean, there's going to be a lot of like relief cuts and stuff like that, and we will have some joints and so on, but as we're going to build up so many layers, we'll just make sure that the joints are not in the same place, and also the unidirectional fibers, they're going to be continuous all the way.
Does it work?
It's super tacky. It's like it works very well. $1.1 kilo. Yeah, we're gonna weigh everything just to make sure that at least when we start the infusion we have an idea of how much resin we should use. It's good to have at least somewhat an idea about how much it should be. So if we are completely off, then we know that something is wrong. Okay, so we have two layers of triaxial, 600 gram, and now we're gonna go on with the unidirectional, which we think we will put on 6 layers of, and then maybe 2 more of these triaxial in the, so we end up in total of 10 layers, which should equal roughly 6 millimeters of carbon. And we did a FEM analysis before. That was done with 4.8 millimeters, so equal to 8 layers. As we don't have all these layers in that direction, I mean, it's not, that was unidirectional 4.8 millimeters. So I think this is a good compromise. Okay, so it's time to release this beast. 60 meters of 600 gram unidirectional. Ooh,
shiny!
It's very shiny. So now we're done with all the layers of the first skin of the beam. It is 10-ish layers of various fabric of 600 gram per square meter. 6 layers of UD and 4 layers of QX, so fibers in 4 directions, 0, 90 and 45 plus minus. Next up is to continue with the infusion stack, decide on where to put the feed lines, feed port, vacuum line. We've had some different ideas forth and back. I mean, at some point we thought that we were going to have a feed line like on each side, all the way around, like a U, and then have this vacuum strip that we tested earlier. But latest and greatest, they can probably change still though, is that we're gonna infuse across the beam. So we'll have the feed line on one side and then vacuum on the other side, and then just infuse across it. The risk for leakage in this is probably quite high. I mean, we have so many potential points of leakages here that, yeah, it's a bit strange to say, but the risk of that we won't be able to get it completely tight is quite high.
A little bit chaotic puzzling here. Doesn't look that pretty maybe, but thought it would work out okay.
We don't want to tape it down too much either, because we did that mistake before, and then when you put vacuum on it, if you taped it too tight somewhere, then it can't really follow all the shapes and contours. All the peel is in place. Next up will be the mesh, and for this part, as there are quite a lot of contours to follow, we bought a more flexible mesh than the. We have some of the old one here. Yeah, the old one is one we used for the flat panels. Maybe you don't see that big difference, but it's a bit stiffer and a bit more difficult to shape. But this one shapes in kind of in all directions. Okay, so we've been thinking forth and back a lot on how to place the mesh here to end up in good resin flow. Obviously we have not done an infusion like this before. Yeah, we've been trying to ask people. I have some colleagues at work that knows a lot about resin infusion, so we've tried to ask about tips from them. We're only going to place mesh a bit more than halfway of the beam, and then we'll let the rest of the part to we will keep that without mesh to make sure that first of all that the resin front slows up a bit, so we really make sure that we infuse all the way down through all our 10 layers, and also that we can catch up if any parts are quicker than the other ones. So the idea is that we're going to try to keep roughly 15 centimeters equally on the whole beam, and as it's the width changes, we'll change or cut the mesh so that we have roughly 15 centimeters everywhere. And then we also decided to use this, I'm not sure what you call it. I mean, it's a vacuum strip with this membrane to make sure that resin won't go through. So we'll place that on the vacuum side, and so this one will make sure that we keep vacuum over the whole side, even though we get an uneven resin flow over the beam. If some side for some reason reach the vacuum port before everything is infused, vacuum will still be kept along the whole way. This is probably super overkill for this type of infusion, but we have already bought it and we're not going to use it for anything else, so we'll just use it anyway. Also, this is meant to be placed on top of a laminate, but because that was our initial idea when we bought it, but we're now going to place it on the side instead.
So we have positioned the mesh, and it looks a bit chaotic. It's quite difficult to get it in place since it's quite wobbly. When we add vacuum on it, we will take it slow, and then we could make sure that everything is where it should be. We have some duct tape to keep it sort of in place now. We're gonna position the resin feed line.
This corner is really tight.
And this is how the hose looks. It's like spirals, so you can let the epoxy out. We have put on the vacuum film. Now we're gonna test to put vacuum and see if it is any leakages. There will probably be somewhere.
And we also put in the resin feed line port, the vacuum port through the bag. I think we're putting maybe not that many pleats, but enough pleats. It feels like there's enough excess bag.
Right now we are currently in the middle of some leakage solving chaos.
Yeah, I'm not sure really what we're doing.
I guess he said that at some point we should just give up and do something else, but we're still trying.
We have had some really big leakages, which was kind of expected, and it's mainly due to small air voids in the old laminate. As you can see here, we tested, we added packet tape. Now we have added another bag on top of the first bag here. Hopefully we have managed to get to places where there are no air voids in the old laminate. Should we try to pull vacuum?
Yep. So we put on this extra bag. After we did that, we realized that on the outside of the mold, especially in the parts we have the window with a little less laminate, we have some holes. I think you can maybe hear it on the camera now, how it hisses. Somewhere here. So now you hear it stop. So what we're gonna do now is put some thickened epoxy on this and hopes to seal it.
It's a new day, and we will continue to try to find the last leaks in the vacuum bag. Hopefully we'll manage to do that, and then we will do the Resin Infusion today.
We don't know if we're trying to save something that it's unsavable right now, but
Hope it's the last thing that's gonna leave us here.
yeah, it is better than it was yesterday after we did the epoxy thing on at the windows, but it's still not good. So maybe this will do.
So the idea is that we have a leakage somewhere in the bag into the core with the cut strips that then propagates. I mean, on this end here, for example, is not sealed at all, so we're not sure if it will be possible to seal it with just tape. It's probably not by the book right now, but yeah, we're getting a bit desperate.
Yeah.
I think the main reason why we were a bit hesitant doing a resin infusion like this onto the part was that it was going to leak, and it still leaks. We've been trying to find leaks for I don't know how long now, forever it feels like. we keep pretty good vacuum, but it definitely drops during a drop test. The first rule of resin infusion is do not try to infuse if it leaks. But we are very close to a decision of violating that anyway now. Maybe we shouldn't. And we have been discussing our emergency plans if it leaks. If it leaks somewhere before the vacuum strip, we will obviously see it when the resin front hits it. Then it will be like bubbles coming up there. Then we can stop the resin feed line and hopefully understand where it leaks, because that's the problem right now. It's such a big area and we have no idea where it leaks. And that way we can maybe fix a leak like that. If we can't fix a leak like that, that's probably the worst scenario. Then let's say it starts to bubble here. Then we assume that then we will get like a air trap, or yeah, like an line of air in the infusion. Hopefully the rest will still infuse, but we'll get that. And our plan then is that we will probably, hopefully then infuse the whole beam, then just release the vacuum, cut the bag at that pace, so we'll basically then end up in more or less like a wet layup, but it's at least hopefully infused and everything is in a good way, but without any compression. And then you just try to work that air out. Then we also have the possibility that it leaks like after all the carbon, somewhere here at the vacuum strip or somewhere else, which is maybe likely because we have had a lot of problems in this area. What will happen then is that then we will most likely be able to infuse it fully, but we will not keep vacuum for the whole curing time, which is maybe of less importance for us, it feels like. I mean, of course it would be good to really have everything fully compressed under vacuum, but we're kind of happy if we make it fully wetted and that everything is in place. So with that, I think we will infuse like this. Also, it feels like it's, I mean, removing the bag and starting all over again, that will not really help us, because I mean, we have been through the tacky tape lines so many times over and over, and I'm quite sure that that's not where it's leaking. It's got to be somewhere else.
Yeah, you can also see it. We put on this tacky tape on the side here where there was open core. Even though we have run the vacuum pump like a lot, it's still not vacuum in this area here that it's enclosed. It's not leaking here, at least on this tacky tape.
No, I mean,
and apart, and this is in the beginning. But here we are very sure that it's not leaking.
Yeah, let's do it. Let's see what happens. Worst case, it completely fails and we have to rip everything up. That would be super sad.
Or it will be a success. Success or disaster. That's
yeah, let's just do it.
Okay.
So it's go time.
Yes.
I don't know why you feel so nervous. There's some money and time invested in it, but it's not that much in it. How nervous do you feel now compared to when we lit the fire when starting to melt the lead for the keel? This is the scariest fire I've started.
Less nervous, but the most nervous I've been so far with the boat is when we were lifting it back into the water. I am nervous now, but nothing compared to that. What about you?
If you think about it and compared to how much potential loss you have, this is nothing compared to both lighting up the fire for melting the lead and lifting the boat with a sketchy lift. This shouldn't be that bad, but for some reason it feels quite nervous.
Yeah.
Let's go.
Yeah, let's do this. Okay, we found some bubbles.
There was a leak in the bag there. I think somewhere here we had a leak. But now it looks like we have caught it.
Yeah, we were in the middle of the run at least, and the front is propagating. It has slowed down here in the middle now because the mesh is ending here, so it is meant to be slower after this part. Yeah, but the air bubbles really seem to be less now.
And here is the legacy of the leak. But I think, okay, so we are a little bit more than 1 hour in since we started to mix the first batch. I think we have around 100 minutes of hot life, and it's super slow right now. It is still progressing, but it's going very, very slow. I mean, we're almost through. We're already through the actual beam in some places. It feels like we're gonna make it. We are through. Which is great, but we are also losing a bit of pressure.
So we still have a leak somewhere.
At least it feels like all the carbon is wetted out.
And we used the right amount of epoxy. Maybe we should have had some more mesh, maybe 1 centimeter.
Yeah.
Because it went like so slow in the end. And we wanted that, so would be sure that it had wetted through all the layers. It also feels like it went a little bit too slow.
I mean, maybe it's the combination of that. We have quite a long, we have like 1/2 meter of infusion length, and then we have like 15 centimeters of no mesh in the end, and that's maybe a bit on the edge. Okay, so we're back at Doghouse after the infusion, or whatever you want to call it. We have completely lost the vacuum, which we knew because we had the leak somewhere. So I'm not sure what you would call this, some kind of infused but then curing without vacuum setup. It's more like a wet layup, I guess, in the end. But let's uncover it and see how it looks like. It is cured. Look at this. So far so good. I think it turned out really, really well. We have some, all these blank areas. It's very hard to see. Actually, I just think it's peel ply has not been laying against those areas. No, I think all in all it turned out really, really well. I mean, there's some areas here, especially in the bend here, which I think is the most critical parts they look really, really nice. I'm very pleased.
Next step with this beam area is to lay up the core.
Yeah, and glue in some core. Well, that's gonna be the next step, to fill this up with core, and that's gonna continue up here, and then in this area, which will be where the attachment point to the deck will be, it's quite difficult to explain, but we will weld like a piece of stainless steel together with some bolts that gonna stick out there that we're gonna attach the beam to the boat with later. That will be laminated in with carbon fiber. For electrical insulation we will have some glass fiber in between, so that the stainless steel is not in direct contact with the carbon, because carbon is electrically conductive. It's always interesting to see how stiff things get. I mean, obviously this is just a single laminate there, so it doesn't add that much strength until you get the core and the sandwich structure. Here, maybe if you film it from the side, you can see.
It moves.
Yeah,
Still.
maybe it moves. Wait until we get the
core.
The sandwich structure in here, then you won't move it at all, I think.
Right now we're waiting for more materials to continue with the beam. While we wait, we're gonna laminate the outside of the walls. But before we do that, we're gonna cut away a little bit of the frame here. Because, yeah, as you can see here, it is quite tight.
It's super tight to get in here. Nice, looks really good. Nice surface. Nicer than what I expected. That was easier than expected. We're missing some parts or we're missing resin. No, not resin, peel ply.
Peel ply.
And resin probably as well for the Doghouse. So we're gonna continue with what do you call it now?
That's the thing, we're not sure. Maybe mast butt or mast foot or
Thing that holds the mast in place.
in the boat.
That's on the boat. Decided to weld a new one. We have started to cut some pieces and we will continue with that. And we have geared up because it's really cold outside. It's really bad planning doing outside job when we could be inside here laminating instead, but yeah. Okay, so we have initially welded the new mast butt, or whatever you call it. This frame is made out of stainless steel. This one is made out of steel. Mast is obviously made out of aluminum. Then this is how it was as before. And the reason for that is that we think that this part acts as a sacrificing anode basically for the masts. As if the mast would stand directly on stainless, then it would be corroding. One thing that is different from the previous design is that before it was more like just a U shape, and then the attachments were in the middle here, and it was also open in the end. All water that came down the mast basically just entered the bilge. The idea now is that we will have this one sealed as well as kind of a bucket thing, and then we will have a small drain here that we can drain to a dedicated spot for like a encapsulated bilge pump or something like that, so that it doesn't end up in the bilge. We also increased it. I mean, this threaded rod is to be able to position the base of the mast. Before it was an M12 rod, but we decided to step up to an M16 instead. Great, so now we're just gonna test it on the mast, and then we will do the final welding and then paint it and then mount it back on the boat.